this GitHub repository is already shared to the students, and so you need to go through these files to understand how to use LangGraph and Ollama to develop agents. So here I just mentioned that I said chemistry agent, chemoinformatics agent, whatever. We are gonna develop agents that can understand molecular structure and do some analysis on the structure using PubChemPy or RDKit. So this is the basic requirements. Install Ollama, and then pull the model, insert necessary libraries, which is already included in the Python notebook files. So you'll see what libraries you're gonna need. But I just put here. You can install all of them with pip install. And you need RDKit and PubChemPy because obviously it's a tool, and to make the model do analysis with RDKit, you basically need these two libraries. And one of the issue I have encountered was this library, LangGraph Prebuilt. It's working well in my laptop, but it didn't work in my desktop. I'm not sure, but maybe it's because of version discrepancy. So I'm going to explain it later, but even if you cannot install LangGraph Prebuilt library, you can still run the model. So don't worry about it. Let's go into the first one. So as I mentioned in the previous video, it's a slight modification of the original resource. So if you're interested in the original source, you can go to Colab or this GitHub. And original version uses OpenAI API, but I didn't want. Well, API requires little cost, although it's very small. But I think without OpenAI API, I thought that it's Ollama models are good enough, and actually my assumption was right. So here we are going to use Ollama instead of ChatGPT. So it's about chain. So in the LangGraph, you need to define workflows, and that workflows is actually chain of the state. In the below figure, we first define start node, and then each node is each step of the workflow. So it's just simple graph, and in the nodes, each state is saved so that the model can do the task based on the workflow. So this first file is the focus. The goal of this first file is to show you how to define the graph in LangGraph. So we're going to use basic function methods provided in the LangChain, which is a chat message and chat models. You can click the link and you can see the details of how they are defined. And we're gonna binding only one tool here, so that the model can download the source code. We'll only use in this first part. We only will use one tool, and that is PubChemPy. And we will execute the two calls. So first install these: LangChain-ollama, LangChain core, and LangGraph. And first, we're actually using language model, and so messages, each message from user and also from the model are defined as a message method here. Human message and AI message. So LangChain supports many different types. You can provide human message, AI message, system message. System message is like message that is given to the model to define the role of the agent. So by providing system message, you can actually control the behavior of the model. If I'm not sure, but if you have defined your own GPTs in OpenAI website, actually you're providing system message to the model, your own GPT, so that it can behave as based on your according to your intention. And last one is tool message, which is important to use the tool calling. Okay, so here we define messages. So here it's, well, actually AI message is basically message from the model, but this is just an example to that we can actually write some sentence as if it's from the model. So here it's the message. If it's saved as AI message, then this message will be considered as a sentence from the model. But one thing important here is this list here. So this message is not just one message, but it's a list. And following conversation is appended to this list. And this list is important because when you have a conversation with chatbot, sometimes chatbot lost context of your of the conversation, and it's because maybe conversation is too long. But if you use API and you didn't define this list, and if you didn't append all the messages, all the previous messages, then model cannot remember the context. That's why it's important to add all the previous messages so that you can continue your conversation with the model. So you said you were a researcher. So this is a message from the model, and say yes, that's right. But if it's not if this conversation is not saved in the list, then actually conversation stops right after this sentence, and you start all over again because the model doesn't have previous sentence. So it's important to have this list. And here we use chat model. There are different way of using the model, but here we use chat model. And for Ollama, we use LangChain-ollama. Well, it mentioned about OpenAI API key, but it's just because I didn't edit this description part. I only edited this part. So we're gonna use LangChain-ollama. And if you downloaded the model already in the Ollama, then you just specify the name of the model and then use the model. So LLM is defined here, and then you can give a prompt with invoke. And messages were the list of this conversation here, and it gives an answer like a message, and this is an answer for the prompt. And here it says tool calls none, and if it gets prompt which requires tool calling, then you will see different result. Yeah, this is metadata of the answer. And now we are moving into tools. So model need to interact with external system, and tool is really helpful to give a good answer. So in the original code, the example is this multiplication. So when someone asks what is 2 times 3, then some of models didn't really do well for the to do the math. But if it has a tool for multiplication, it can give a good answer. But when I tested Q1 2.5 0.5 billion model, it gives quite accurate answer without tool for doing simple math. But anyway, this is an example. So the model never get wrong answer if it has a tool. So how we define tool? It's pretty simple. This is all. this, well, it's just a normal Python function, but something different than the normal function is this one. So this is a variable given to the function, but you see this colon after integer, and also colon after integer, and here arrow and integer. And then you have this comment line here, and this information is the key for the model to decide whether the model should use the tool or not. And this additional information is giving a hint to the model that you actually need to prepare integer values, 2 integer values to use this tool. And if you use this tool, you'll get return value, which is also an integer. That's the hint here. And this additional information is Pydantic grammar. And also this comment. So without this comment, and I think model can still find the tool without this, but I think but these lines of comments are essential for model to find the tool. So it says multiply A and B. So if someone asks what is 2 times 3, then based on this prompt, it searches tools. Well, in here there's only one tool, but you can give more tool. Just not just one, but more than one, like a 2 or 3, more than, or maybe 10. And language model finds the appropriate tool based on the information here. So that's why it's important to give a comment within the function. And then you can simply bind the tools, and then it will use this tool when answer the question. So here the example is that now LLM is defined as LLM with tools, and I ask a question with a human message, what is 2 multiplied by 3? And it says, it gives something, and you actually see that the model decided you should use tool call. So it will call the tool, and it realized that the 2 variables to the tool should be these 2 values, which is taken from the user prompt. And it says, okay, name of the function is multiply. So when user asks a question, and based on this prompt, it decides that, okay, I should use this function to give an answer. Okay, so if the model find the tool, you will see this. And if the model fail to find the tools, then you don't see such information. All right.